Let's talk about the matrix equation, AX equals B. We define the product of a matrix and a vector in an unusual way. So we've got this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, and this vector 10, 20, 30. So here's how we multiply together the matrix and the vector. It's going to be 1 times 10 plus 2 times 20 plus 3 times 30. That'll give us the first row. The second row of this product is going to be 4 times 10 plus 5 times 20 plus 6 times 30. In other words, 320. And then you can probably guess what the last entry is going to be, that bottom. 7 times 10 plus 8 times 20 plus 9 times 30. In other words, 500. So the product of this matrix and this vector is 140, 320, 500. Here's why we represent matrix multiplication in that seemingly bizarre way. It's so that we can use it to solve systems of equations. Let's represent the system of equations x1 plus x2 plus x3 equals 4, x1 minus x2 minus 2x3 equals negative 7, 3x2 plus x3 equals negative 1 as an equation involving a matrix. So here's how we go about doing it. You take the coefficients 1, 1, 1, 1, negative 1, negative 2, 0, 3, 1. That's your coefficient matrix. And then you multiply that by the vector x1, x2, x3. And then this 4, negative 7, 1, that's just going to be the vector on the other side. So notice that what I've represented, what I have here is just a representation, matrix equation representation of this system of equations. Because we have 1x1 plus 2x2 plus x3 equals 4, 1x1 minus x2 minus 2x3 equals negative 7, etc. By the way, we've seen before that the solution to the system of equations is 1, negative 2, 5. Now, what I'd like you to notice is that if you're talking about this system of equations or this matrix equation, it can be rewritten in this way. It's x1 times the column vector 1, 1, 0 plus x2 times 1, negative 1, 3 plus x3 times 1, negative 2, 1 equals 4, negative 7, 1. And you can see this because, you got x1 plus x2 plus x3 equals 4. That's the first equation here. Another way of thinking of this, okay, so if we can rewrite it like this, here's another way to think of it. This is a linear combination of the column vectors 1, 1, 0, 1, negative 1, 3, and 1, negative 2, 1. In other words, 4, negative 7, negative 1 is a linear combination of the vectors 1, 1, 0, 1, negative 1, 3, and 1, negative 2, 1. It is, if indeed there's a solution to the system of equations. So this system of equations has a solution if and only if 4, negative 7, negative 1 is a linear combination of the column vectors 1, 1, 0, 1, negative 1, 3, 1, negative 2, 1. Another way of putting it, this system of equations has a solution if and only if 4, negative 7, negative 1 is in the span of these column vectors.